My name is Professor Bob Stone and I'm the Director of the Human Interface Technologies team within the School of Engineering here at the University of Birmingham. My session is going to be an extension from what I presented about 2 years ago now, what was trauma innovation. And at that conference we presented an early concept for a low-cost redeployable trainer for future medical emergency response teams. And what we're using is something called mixed reality, where what we're trying to do is to blend the best of the real with the best of the virtual. In other words, using real physical objects, such as an inflatable enclosure and a realistic looking human mannequin, to make the virtual interior of, for example, the Chinook helicopter a lot more believable to the future trainees. The original project was entitled the Mixed Reality Trainer for Medical Emergency Response Teams, and it's sponsored by the Royal Centre for Defence Medicine. And the original enclosure actually took the form of an inflatable tunnel, if you like, in which we put a number of physical objects, everything from replica weapons to a very realistic looking human mannequin. And the idea was that we would put somebody into a virtual reality headset and they would have the experience that they were inside, in this case, a Chinook helicopter. And the idea there is that they could then interact with the virtual patient, but they'd be able to actually feel the real patient. And it's this idea of mixed reality, bringing the real and the virtual together to actually create a believable illusion that you're on board a real aircraft. Since we presented this concept at the last Trauma Innovation Conference, as it was called, things have moved on at an incredible pace. We've now moved away from an enclosure that consists of all these physical artifacts, the machine guns, the seats, the Bergen backpacks and so on, but we have retained the physical mannequin because that's a central part of our training. But what we've done is we've developed a completely new enclosure which is completely blue screen inside, so we can chroma key the effects onto the actual interior but retain a physical view of the actual mannequin. Now what that means is you can now put that on the virtual reality headsets, which are modified using a camera. You can look down and you can see and touch the real physical mannequin. So no need to wear any of these cumbersome, unreliable haptic feedback gloves as they're known. But you can actually see and touch the real thing. But when you look up, you're still within the virtual Chinook or the virtual hovercraft or the virtual landing craft. That's almost a world first and something we're particularly proud of. And now when you also look around for example, the Chinook, you can also see animated characters. So we have the pilot, the co-pilot, who are carrying out tasks on the flight deck, and we have a minigunner who is at his station looking out of the window, scanning the environment for any threats to the aircraft whilst in flight. So lots more to do, but we've made incredible progress since the last presentation. Members of the Armed Forces have been absolutely crucial to the development and success of this project. For example, the Royal Marines at Her Majesty's Naval Base in Devonport, they very kindly put on a landing craft and a couple of hovercraft for us to go up and down the River Tamar and carry out filming using a 360 panoramic camera and a pair of GoPros, so that we can actually use the video footage to create the illusion of these platforms in motion. Without their help, this project simply wouldn't have happened. Similar support from the Shrivenham guys, the Royal Military College of Science in Shrivenham, who put on a massive land vehicle for us to do something very similar with. And last but not least, of course, are our colleagues at the Royal Air Force Tactical Medical Wing at Brize Norton, who sent a delegation of experienced individuals up to our laboratories to carry out an initial usability trial a few months ago, which has provided such incredible feedback that we've now been able to move on to the next phase of development with the Armed Forces guys very much behind us. What we have to do over the coming 12 to 18 months, in fact, is to develop the enclosure and develop the whole training concept so that we can actually take it out to the various armed forces, like the Technical Medical Wing at RAF Brize Norton, for example, and carry out a series of intensive trials to make sure that the training concept actually works. So hopefully we'll be working with the Royal Air Force, the Army, the Royal Marines and the Navy, but taking the enclosure around to different bases in order to carry out trials with armed forces personnel to see what they learn, and importantly, do they retain the learning and can they transfer that learning into a real world setting. One of the main things that we've demonstrated yet again in this project is the importance of adopting a strong human-centered design, human factors approach from the outset. We see time and time again online various projects taking on board virtual, augmented and mixed reality technology without any concern to what the actual human end user needs. And this results in projects that simply don't deliver. So the main message, once again, as it was last time, is to prove that by adopting a human factors approach at the outset, you can actually deliver a technology-based training system that is fit for purpose.